Hi! Great way to get ready for the SATs is by doing practice problems. So I'm going to take you through the entire non-calculator math section of Test 5 with full explanations of all the answers. So I'm going to take you through an entire section of Test 5. So there are 8 full practice tests available from the college boards on their websites. Here's the one we're going to do, number 5. They're also available on Khan Academy. So you can pull the test there and then watch the answers here. So there's a number of different ways that you could use this to get ready for the SATs. You could do the whole section on your own first and then watch this video to compare answers and see which ones you got stuck on. You could just watch the video straight through to get strategies of how to handle SAT problems, or you could do it problem by problem. You could pause, try the problem yourself, and then watch the answer. So whatever works for you, let's get started. So as I go through the problems, I'm not at all suggesting that this is the way you would actually take the test. I'm going to take a look at a couple different ways to do each problem. I'm going to look at possible shortcuts or different ways you could approach the problem. So this is more of a learning experience, not a demonstration of how you would take the test. So number 1, we're looking for the equation of the line here. So if we remember y equals mx plus b, b is the y-intercept. On the graph, the y-intercept is 1, and the only one with a y-intercept of 1 is right here, and our answer is D. Now another way to look at this, anytime you want to find out if a point is on a graph, so here 2, 3 is another point on this graph. So we could take 2, 3 and see which one it works for. So x equals 1, no. Y equals 1, no. Y equals x, no, they're not equal to each other. Y equals x plus 1. So 2 plus 1 is 3. Yep, that works. So that's another way to look at this. If you didn't know what the equation was, or if it was a more complicated problem, we could take a point and then see which one it works for. But our final answer here is D. So in this problem, we're looking for minor arc AC, which is right here. We know that the circumference is 36, so all the way around the circle is 36. And we know that this is 90 degrees. So all the way around a circle, the internal angle is going to be 360 degrees. So we've got 1/4 of that. We've got 90 over 360, or 1/4. So if we've got 1/4 of the internal angle, we're also going to have 1/4 of the circumference. So 1/4 of 36 gets us 9. Another way to look at that too is if you've got 360 degrees all the way around, and that's 36, then that's 1/10 of the degrees is the length. So for 90 degrees, 1/10 of that is going to get you 9. Just another way to look at the ratio. But either way, we get 9. All right, in this problem, we're looking to solve for x. The equation is already set equals 0. So let's take this equation and factor it. The first thing you always do with factoring is look for a greatest common factor, and we can take 4 out of here. And then since it's set equal to 0, we can divide both sides by 4, which gets rid of our 4. Then we're going to factor here. We're looking for 2 numbers to multiply to -3 and get us a sum of -2. So x minus 3 and x plus 1 is going to get us -3 when we multiply them and -2 when we add them. And then we set each one equal to 0. X minus 3 equals 0 when x equals 3, and x plus 1 equals 0 when x equals -1. So it's -1 and 3, which is choice B. Now I want to show you another way to do this one as well. So if we take a look at the answers, we've got -1 and 1 and -3 and 3. So really all we have to do is check which one works out of 1 and -1 and 3 and -3, and what's another way to get our answer rather than going through the whole factoring. Right, so let's see how that would work. So if we're talking about this equation, and let's try 1. So 4 times 1 squared is 4, minus 8 times 1 would be -8, minus 12. That does not equal 0. So our choices with 1 are not going to work. And then we just have to check 3. So if we put 3 into here, 4 times 3 squared, 9 times 3 is 36, minus 8 times 3, which is 24, minus 12. Does that equal 0? And yes, it does. So out of the choices of 3 and -3, 3 is the one that works. So -3 doesn't work. 3 works. So that's another way to get to our choice B. Okay, so this problem is asking us, which of the following is an example of a function whose graph has no x-intercepts? And then they're asking us about real zeros. So if we've got some kind of function that doesn't hit the x-axis, where it hits the x-axis is going to be the real zeros. So that's where you find the real zeros, is on the x-axis. So a quadratic function with real zeros is out. A cubic polynomial with at least one real zero is out, because that's going to touch the x-axis at that real zero. And now the only other thing is to take a look at a linear function whose rate of change is not 0. So as long as it has some kind of slope, no matter where that line is, at some point it's got to hit the x-axis. So that one's out. And our answer for this is going to be C. Okay, now in this problem, first of all, we've got this x in here, and we've got x equals 9. So just let's go and put 9 in there, and forget about the fact that x is in there. Okay, so a couple different ways to do this one. So we could just think about it logically. So if we've got something that we're going to subtract 9 from and get 0, then this all has to be 9. So if we're going to take the square root of something to get 9, that's going to be 81. So k plus 2 has got to be 81. And then, so if k plus 2 is 81, then k has to be 79, or D. So that's the way to think through it logically. Now let's do it algebraically. So if we were to solve this, what we would do is add 9 to both sides. Now to get rid of a square root, we're going to square. So we square both sides. K plus 2, the square root of it squared is just going to be k plus 2. We square the 9 and we get 81. Subtract 2 from both sides, and we get k equals 79. So another approach to get the same answer. Yet another way to look at it is we could just plug in these 4 answers and see which one works. So let's plug them in. 1 plus 2 is 3. The square root of 3, that's not even an even number, so that's not going to work. Let's plug in 7. 7 plus 2 is 9. The square root of 9 is 3. 3 minus 9 is not 0. The third one, 16 plus 2 gets us the square root of 18. That's not an even number. 79 plus 2 is 81. Take the square root of 81. It's 9 minus 9 is 0. So that's another way to do it. Without going through the math, we could actually do plugging in the answers, and then we would get to the same answer. There's 3 different ways to get to the same answer. When you're doing the test, just whatever the quickest and most confident way is for you to get there, as long as you get to D as the answer. Okay, in number 6, which of the following is equivalent to the sum of the expression a squared minus 1 and a plus 1? This is worded a lot more complicated than it has to be. All it is we're saying the sum, so we're going to add these two things together. So what is a squared minus 1 plus a plus 1? The minus 1 and the plus 1 cancel out, and we're just left with a squared plus a, which is answer A. Okay, in this problem, very long, complicated problem, but what I want you to do is let's focus on the answer first. So we don't really have to come up with the equation because they've come up with the equation. If you notice, the equations are all the same in all 4 answers. It's just a matter of which way this inequality goes and which way this inequality goes. So what we read in the question, we just need to understand which way the inequality is going. So she's working for 12 an hour, $9.50 an hour. The important part is she wants to work no more than 20 hours per week and earn at least $220 per week. So this first part, this and this, tells us how much she's going to make. If we take and multiply 12 times the number of hours and 9.5 times the number of hours, that's going to get our total money. If we say it has to be at least 220, we're okay if it's more than 220. It just can't be less than 220. So for this sign, it's going to be greater than or equal to 20. It has to be 220 or more. Now let's take a look at the hours. No more than 20 hours. So no more than that means it has to be that or less. So this sign on this equation has to be less than or equal to. And then we just look through the answers and see which one has less than for the second equation and greater than for the first equation. And that would be right here, answer C. So we've got an equation here that has to do with the speed of sound, S, and the air temperature, T, and it's asking us for the interpretation of the 331. So in any linear equation, the constant is going to be where the variable is equal to 0. So if you look at that graphically, it's the y-intercept. So the y-intercept is going to be where your x equals 0. And if you look at it here, if you plug in 0 for t, this becomes 0, and then the speed of sound just becomes that constant. Okay, so then the answer is going to be the speed of sound in meters per second at 0 when the temperature is 0, or choice A. Okay, on this problem, we've got two equations. We're trying to find what x and y is the solution for that. Now, it's important to notice that it's got two things here. One, that it's telling us that x is greater than 0. And then it's also, what we're looking for is the product of x and y. We're not looking for x or y, we're looking for the product of x and y. So those are important things to notice. So we're going to take, since y equals x squared, we're going to take and substitute in x squared for y. And our equation becomes 2x squared plus 6, and then let's multiply this out, equals 2x plus 6. Subtract 6 from both sides, and we get 2x squared equals 2x. Let's set it equal to 0. 2x squared minus 2x equals 0. Factor out a 2x. So now each of these are going to equal 0. So 2x is going to equal 0 when x equals 0, and x minus 1 is going to equal 0 when x equals 1. But remember, the equation told us that x has to be greater than 0. So that takes that solution out, and we get x equals 1. But we're not trying to find x, we're trying to find x times y. So if we plug this back into the first equation, if x is 1, then y equals 1 squared, or y also equals 1. And so x times y is going to be 1 times 1, or 1. So our final answer is A, which is 1. All right, in this, we're trying to find 4z plus 8y. So we have the value of z right here, and we have the value of y right here. So to find 4z plus 8y, we just substitute those values in. So for z, a squared plus b squared, so 4 times a squared plus b squared. And for y, we're substituting in ab. So we get 8 times ab. We're going to distribute the 4. Now, this doesn't match any of our answers, so we've got to take another step. We've got to take and multiply these out, do these perfect squares, and see which one matches. Now, if you remember how perfect squares go, perfect squares are going to be the first term squared plus twice the product of the two terms plus the last term squared. So which one of those is going to get us this? Well, right here, if we square 2a, we're going to get 4a squared. The product is going to be 4ab. Twice the product is going to be 8ab. Square the last one, and we get 4b squared. So our answer is going to be here. If you didn't remember how to multiply out perfect squares, we can actually just look at just this term. So when we square this, the term that the first term that we're going to get is going to be a squared, or a squared. For the second one, we're going to have 2a squared, which gets us 4a squared, because we're squaring the entire 2 in a. When we square 4a, we're going to get 16a squared, and when we square 4a, we're going to get 16a squared. So for the first term, the only one that works is also b. So that's another way to do it. Rather than multiplying the whole thing out to see which one matches, we can just look at one of the terms. That's another way to do it. So b is going to be our answer for this one. So we have a cylinder with a volume of 22. And it's asking us what's going to happen to the volume if we double the radius. So the radius is going to be doubled. And we take half the height. So the height, we're going to take half the height. So this is actually one of the times when we can actually use the equations on the first page here. So let's pull up this equation here. So V equals pi r squared h. So if the radius is going to double, then that's going to make the whole answer go up by 4 times because we're squaring that. And then if the height is cut in half, it's going to make the whole thing cut in half. So if we're multiplying by 4 but dividing by 2, it's going to double. So we're doubling this 22 to get 44. So we can also do that with numbers. So that if you got lost in that explanation, let's assume some numbers. So we're going to pick values for unknowns here as a strategy. So we're not going to be able to get the 22, but let's do something to see what the ratio is and then apply that to 22. So what if I had a radius of 2 and a height of 8? So let's use the formula. So we would have pi r squared h. So we would get 4 times 8 times pi, or 32 pi in this case. Now if we're going to double the radius then becomes 4, but half the height then becomes 4. So let's put this into the equation. So pi r squared h, r squared is going to be 16, h is going to be 4, and we get 64 pi. So here's another more concrete way to show that whatever we have for a volume, if we double the radius and take half the height, we're going to double the volume. So we're going to double the 22 and get 44 as our answer. Okay, this problem requires us to understand what an exponent of 3/4 means. So we're going to have the root of 9, but it's going to be the 4th root, which is the denominator. And the cube, we can either cube it here, or we can cube the whole thing. These mean the same thing, actually. So let's take a look at the first two answers that involve 9. Notice 2 of the answers involve 9, 2 answers involve 3. So if we're taking the cube root of 9, that's in the wrong place. So that's not going to work out. We want the 4th root because the denominator ends up being the root and the numerator is the power. The second one has the 4th root of 9, but it hasn't cubed it. This would actually be the same as 9 to the 1/4. So that's wrong. So now these two answers have 3 in it. So we've got 9 and we've got our answers that have 3 in it. So we've got to actually change this over. So if we realize that 3 squared is 9, then we can rewrite the original problem like this. Then when we take an exponent to a power, we're going to multiply the 2 and the 3/4. So this becomes 3 to the 2 times 3 over 4, which is 3 to the 3/2, which is the square root of 3 squared. Well, this one is only the square root of 3, not the square root of 3 squared, so that's not right. And we end up with this. But this is to show you a little more how we would get this. Oh, I'm sorry, that would be cubed. So this would be the square root of 3 times 3 times 3, because we could also cube on the inside. And then 2 of the 3's would make 9. We take the square root of that and get 3 square root of 3. Gets us to that answer. So the main trick here, though, is realizing that we've got to take our 9 and convert it to 3 squared to get an answer with a 3 in it. Okay, in this problem it says we have n cups of tea that are made out of tea bags. So n cups from tea bags, and it gives us a relationship that t equals n plus 2. How many additional tea bags are needed to make each additional cup? Well, the easiest way to look at this relationship. The relationship between the two variables of how one is affected by the other is determined by the slope. And the slope of this equation is 1. And we get 1 as our answer. Now, if you didn't see that, and you got confused about the 2 or whatever else, we could set up, we could pick values. We could use a strategy of picking values for unknown values. So let's say we had, in this relationship, t equals n plus 2. So say we've got n is 10, then t is going to be 12, And let's pick another example. What if n is 20? Then t is going to be 22. So let's take a look. To make an additional 10 cups, we need 10 more tea bags. So again, the ratio is 1 to 1, and we just need one additional tea bag for every cup that we're going to make. All right, we're looking for the graph of a function. We've got this function here, but we're not looking for the graph of that function. We're actually looking for the graph of negative of the function. So if we remember what our graphs look like, then this can become a little bit easier. 2 to the x is going to look like this, where it goes through 1. 2 to the x plus 1 is going to take and move that up by 1. And then negative, if we negate the function, it's going to reflect it over the x-axis and look like this, which is the same as c. Now, if you didn't remember what your functions look like or how the translations of those functions work, we could just take a look at the numbers. So let's take a look at where x is 0. So where x is 0, we've got 0, 2 in this one. We got 0, negative 1 in this one. 0, negative 2 here. And 0, negative 1 here. And let's see if that helps us solve this. Now, if we get both, if we negative 1 works, then we would have to decide between these two. But let's see how we would do that. So 2 to the x plus 1. If x equals 0, then that's going to be 2 to the 0 plus 1. Anything to the 0 power is 1. So we get 2. But y equals negative f of x, so y is going to equal negative 2. So when x is 0, y is negative 2. So that gets us right here, and that gets us c. Another way to get c as the answer. And you could have picked when x equals 1. That's another option. The only thing you need to remember is if you get two of them that are the same, then you got to pick another value and see where that works. And that gets us c as our answer, either one of those methods of doing it. Okay, Alan drives 100 miles each week currently. His car can travel 25 miles per gallon. I'm going to write that down here. 25 miles per gallon. Alan would like to reduce his weekly expenditures by $5, so he wants to go down by $5. And we also know that gas costs $4 per gallon. And what are we trying to find? So we're trying to determine how many fewer miles he needs to travel to save that $5. So we're trying to go from m number of miles, and we're trying to figure out how we're going to get $5. So we can take a look at what we need to multiply by. So we've got miles. If we multiply, and we're trying to get dollars, right? So if we multiply by miles per gallon, we would get miles squared, and that's not going to work for us. So we know here we've got to multiply by gallons per mile, because that's going to cancel out our miles and be left with gallons. And then to go from gallons to dollars, right, we're going to use the 4. So we're going to multiply by dollars per gallon. So if we do this, the miles will cancel, the gallons will cancel, and we see that our dollars equal our dollars. So now just let's put in the numbers. So m is our unknown. Now usually you talk about miles per gallon, but here we need gallons per mile, so we're just going to flip it over. So we've got 1 gallon for 25 miles. And then the dollars per gallon is going to be $4 per gallon, and we want that all to equal 5. And again, the miles cancel, the gallons cancel, and we get 4 over 25 times m equals 5, or answer D. Okay, in this problem, Maria is renting a boat at $60 per hour, but then she also has to pay, no matter how many hours, she's got to pay $10 for a water safety course. And she wants to spend no more than $280. If the boat rental is available only in whole number hours, so here's an important part of the problem, whole number hours. What's the maximum number of hours for which Maria can rent the boat? All right, so let's set this up as an inequality. So it's going to be $60 times the number of hours plus that $10. And it's going to be $280, but we want to spend no more than. So the amount we're spending here has to be less than or equal to $280, because we don't want to spend more, but we can spend $280 or less. So now let's solve this. Subtract 10 from both sides. 60h less than or equal to 270. Divide by 60, and you get h is less than or equal to, now there's no calculator here, but we can still divide this out. So it's going to be 4.5. So h has to be less than 4.5, but it's got to be in whole number hours. So 4 would be the biggest number that's going to be less than 4.5. 5 is going to be too big, so 4 would be our answer. Now let's take a look at this another way too. Rather than setting up the inequality, even though we're not given answers here, we can take a look and say, well, for $60 an hour, for 280, in whole numbers, it's going to be something like maybe 3, 4, or 5 hours, right? So then we can calculate what 3, 4, or 5 hours would look like. So 3 hours is going to be 3 times 60, 180, plus our 10 gets us 190. For 4 hours, 4 times 60 is 240, plus our 10 is 250. For 5 hours, 5 times 60 is 300, plus our 10 is 310. So to spend no more than 280, this would work, and this would work, but this would not work. This is more than 280, so we can't spend here, and we're looking for the maximum number. So 3 and 4 would both work, but we want the maximum number of hours, so again we get 4. Okay, what's the value of p in this solution? Now, don't make the mistake of thinking that it's set equal to 0 and thinking that p should be 1 or negative 1. We need to calculate this all out. So we need to multiply by distribution here and get 2p plus 2. And then multiply this by distribution and get 8p minus 8 equals 5p. Then we're going to combine our like terms. The 2p and the 8p are like terms. We're going to get 10p. 2 and negative 8 gets us negative 6. Now we can subtract 10p from both sides. we get negative 6 equals negative 5p. Divide by negative 5. And we get p equals 6 over 5 as our answer. Now let's talk about how we would put that into the grid for 6 over 5. If we have an answer of 6 over 5, we could simply put 6 over 5 like this. If you divided 6 over 5 out, we would get 1.2. So we could also go 1.2. We could also do as well. If you take this and reduce it to a non-improper fraction, we could get 1 1/5, but this is not, we're not able to answer this way. Because if we put 1 1/5, it's going to take it as 11 over 5 and interpret this as a wrong answer. So you've got to be careful when we're entering our answers not to do it this way. So you can either put 6 over 5 or 1.2, but we can't do 1 1/5 because it'll take it as 11 over 5. Okay, number 18, we've got a system of equations. We're trying to find x. So we can substitute in here y equals 2x. So we can actually substitute in 2x for y, or y in for 2x. But since we're solving for x, it's going to be easier to put the x's in for y, because then we'll get x right away. If we did it the other way, we'd have to get y and then calculate x after the fact. So we're going to put in 2x for y and get 1/2 of 2x plus 2x equals 21 over 2. So 1/2 of 4x is 21 over 2. Half of 4x is 2x. And let's divide both sides by 2. Now this gets a little tricky to divide by 2. Dividing by 2 is the same as multiplying by 1/2, another way to look at it, and get 21 over 4. You could have also, from this step, if you had 2x equals 21 over 2, some people might find it easier to put this over 1 and cross multiply and get 4x equals 21, and then divide by 4 and get 21 over 4 that way. Either way, we're getting 21 over 4 as our answer here. Okay, for number 19, we've got this expression here, subtracting two fractions. And it's saying that that's equivalent to a over x plus 2 squared, where a is positive constant, and x is not equal to negative 2. They have to tell you that x is not equal to negative 2, because that would just make the denominator 0. So what we've got to do is we've got to get this expression over a common denominator of x plus 2 squared. So the first term is already over x plus 2 squared. But on the second term, we're going to have to multiply the top and bottom by x plus 2 to get it over x plus 2 squared. So then we're going to get 2x plus 6 over x plus 2 squared. And here we're going to multiply this out by distribution and get not equals minus 2x plus 4 over x plus 2 squared. So now let's take the numerator, because now we have the denominator equal to this, right? We've got the denominator equal to x plus 2 squared. So our numerator is going to be what a is equal to. So 2x plus 6 minus 2x plus 4 equals a. So when we do this minus, we have to make sure that we're subtracting both things. So it's 2x plus 6 minus 2x, and here's a mistake some people make, not plus 4, but minus 4. The minus applies to both the things in parentheses, so we need a minus 4. Then the 2x and minus 2x cancel out. 6 minus 4 is 2, and we get a equals 2 for our answer. All right, and the final question here. So we're going to find this angle here. We're given these two angles. So first we can find what this is, because we know that 106 plus this angle form a straight line, or 180 degrees. So 180 minus 106 gets us 74. So this angle here is 74. Now, if you remember the exterior angle theorem, you would say that, okay, well, this exterior angle is going to equal 74 plus 23. So x is going to equal 74 plus 23, or 97. But if you didn't remember the exterior angle theorem, no problem. We can just do one more step to get this angle first. So these three angles are going to add up to 180. So 180. And these two angles already add up to 97. So 97. So this angle here, to make up 180 for this triangle, is going to be 83. Then we look at these two angles, x and 83. Those have to add up to 180 because they form a straight line. So you go 180 minus 83, and you get the same 97. Thanks for watching, and if you have an SAT coming up, good luck. I'm going to continue to add SAT material, so if you'd like to subscribe right up here, you can get notification of when new material comes out, and I've got some more stuff for you to watch right here. Thanks again for watching, and please come back soon.